This is a MathCad tutorial that will show you how to access Excel data from within the MathCad spreadsheet, either by directly embedding an Excel spreadsheet into the MathCad spreadsheet, or by accessing an external Excel spreadsheet that is linked to, or whose data is linked to, by the MathCad spreadsheet. So first I will show you the embedding process. You can embed several types of components, including the Excel spreadsheet, by clicking on the component item here. You can also access it from the Insert Component item. We'll pick Excel. We're going to create it from an empty worksheet instead of from a file. And then let's look at the data we're going to insert before we fill this page out. So here's the data that I'm importing. I've got an independent variable frequency, and I've got 3 columns of data. The rest of this to the right are calculated quantities, which I'm going to do within MathCad. I just want to get the raw data. So I'm going to go ahead and Control-C, copy that, go back over to MathCad, and we're going to set the input to 0 because the inputs are data that would flow from MathCad into the spreadsheet, so we can move data both ways. In this case, I'm not interested in passing data into Excel. I'm only interested in returning data from Excel, so those are the outputs. I could return one single two-dimensional array that would encompass that data that I just copied. In this case, I'm going to select 4 one-dimensional arrays, one for each column. The first output is going to be from A2 to A7, so A1 has the header frequency in it, so our data starts at A2 and goes to A7. We have B2 to B7, C2 to C7, and D2 to D7. Click Finish, and it inserts the spreadsheet. Now we can double click on it, and you see the menu changes to an Excel type menu, and this little window is an Excel as our Excel worksheet. So I'm going to Control-V, I'm going to paste in the data we copied from the Excel spreadsheet, and then I can resize this. If you grab the handles, you can hide data that you're not interested in showing, or rows and columns that you're not interested in showing. I'm going to change the formatting of this column. You can click the font, Format Cells, or Control-1. I'll bring that up. I want custom formatting, and I can do general or whatever, but I'm going to do single precision, and then in parentheses Hertz. So there we go. All right. That's it. Our data is now available, but in order to use it, we need to assign variables to these placeholders so that they can be populated with the data that's in Excel. So this first placeholder is from column 1, the first output, which we set to be A2 to A7. That's the frequency, and I'm going to call that I'll just call it F sub D for data. Second one is delta is DT. Let's do DT of D. Actually, I'll do capital D, Control G, and then X sub D, Y sub D. There we go. If you don't like, you can tidy this up to make it look better. I'm going to copy this. I'll paste this here. You don't have to do this next step, but I don't like the look of the table and these variables being offset. So you can right-click on the spreadsheet and hide arguments, which makes this look a little tidier. And then this is just a paste of the arrays that are being returned. I can just set that next to it, and they're not linked together, but it graphically shows me what I've hidden. So now I know which variables to use. We can try this out by just typing F period D, F subscript D, hit equal, and sure enough, we see the first column of data. X of D, same thing. Now I want to add units. MathCad is great with units, so let's add some units. Actually, I'm going to go back and put what I'll do. I'm going to change this to raw, 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 raw data. Okay. F sub data is equal to F sub raw data times the units are hertz. Okay. Oh, doesn't think it knows that. Aha. Well, I just got bit by this. I only changed it here. I need to show my arguments, and I really need to change it here. Yeah, it's dangerous practice, but so delete. Well, I shouldn't have messed with it. There we go. Right click, hide. Okay. You can also do view rulers. Oops. Use taskbar view rulers, and I can put some tabs on here. So that when I type something, I can hit tab, it'll go to the next spot. dt data is equal to is equal to dt raw. But now the units are microseconds, so m control G seconds. Yeah, that didn't work so well. I put my tabs too close together. This didn't exactly line up. Okay, and then the next one is x of data is equal to x of raw times, and it's millivolts, yes, and y sub data is equal to y sub raw times millivolts. Okay. Okay, my tabs really didn't work that well because I didn't choose them very judiciously. Now we want to define, remember, well, in this case what we're interested in is taking the ratio of y to x. That would give us the magnitude gain of the transfer function of this system that we've measured. So I'm going to say mag data is equal to the ratio. I'll say y data divided by x data. Okay, and then we'll say phase. I want the phase, also the argument of the data is going to be equal to delta time divided by the period, which is the same as multiplied by the frequency, and then we're going to put that in radians per second. So I got to multiply it by 2 pi. Okay, now let's just try this. I type mag sub data. I do get a 6-element array, and it looks about right. Here I've got a gain for this particular set of data, which is different than what you're doing in the lab. I have a gain of about 9 here, or 10, and that's what I show here, and then by this point I've got something that's closer to 1/10. Okay, let's try the phase data. Ooh, okay, there I get a single scalar value. What's happening here is that evidently when we do the product between these two, it is multiplying delta t times frequency, adding that to this product, which adds to this product, adds to this product, and is returning a scalar value. It's not what I want. So what you need to do is use what's called the Vectorize operator, and that's found on the matrix toolbar. So up here, vector and matrix toolbar, you click on that. There's a shortcut key, but I'll show it to you right here. Initially, see that arrow over a function is called Vectorizing. You can access it by doing Control -sign. So what you do is you select the operator and the 2 arguments that are being operated on. In this case, it's delta t and f in the product. Once you've selected those, press Control-, puts a bar over it. As soon as I do that, the result now is going to be a vector. What it's basically saying here, when you put the arrow of the vectorize over here, it says take every element of the first argument and combine that with the first element of the second argument and apply them as arguments to the operator, and then create an output array or vector that's going to hold that first element and do it element by element. Okay, it turned out in this case, because of division, I'm not clear on this, but it went ahead and vectorized it. But I guess to be consistent, I should do vectorization on that as well. It doesn't change my result. Okay, so there we have that. Now we're ready to plot. So let's insert a graph. A graph here, and we're going to plot f sub data on the horizontal and mag data on the vertical. I'm going to do this on a log, so I'm double click to open up the plotting or the graph, the graph dialog box. I'll turn on grids, change the color, because although I like green, I don't like it for my grid lines. There we go. Because we're plotting data, they're discrete points, it's better to actually change the formatting of the graph so that it actually shows symbols. So let's say I put a triangle in here and make it a little bit bigger. I'm going to get rid of the line. I'll put a dotted line, but that's going to indicate to me that these are just, it's interpolated between the two, but it's only where the symbols are the actual the data set that I'm plotting. Okay, I'm going to copy this and paste it below so that I can plot the phase. So here I'm going to replace mag with phase, and I don't want it on a log, I want it on a linear log. So uncheck the y-axis log. Oops, okay, and the other problem is I made a mistake here actually. The delay we're talking about here is or the delta t is a delay, so it's actually a minus sign. Okay, and then finally I want to plot this in degrees, not radians, so I divide it by degrees. And now, this asymptotically would normally go to minus 90. The circuit that I'm measuring, which happens to be an op-amp low-pass filter, it actually continues to lose some phase here. Okay. Okay, the next thing we want to do is actually plot the theoretical data along with this. So I'm going to make some room here. And let's see, we had, this was the response of an RC low-pass filter. So we had R1 was equal to 1 kilo ohm, and C1, try that again. C1 was equal to 100 nanofarad, I think. Oh, now these tabs are getting in my way. Get rid of there. Get rid of them. Okay. Tau was R1 times C1, and our pole frequency was 1 over tau, which was equal to, let's say, radians per second. Okay, so 10,000 radians per second. Our transfer function, h of s, I'll say h1 of s, is equal to 1. In my case, it's 10 over, because this op-amp circuit had a nominal gain of 10. So it's 10 plus s times omega sub p, there's the minus 1. All right, now we are ready to add this theoretical response to our plot. So select that, press comma, and now I'm going to say vertical bar, that's magnitude of h sub 1 of 1j times, I'm going to write 2 pi instead of just omega, 2 pi times frequency. Now I'm going to actually define my own frequency here, and I need to plot this versus frequency. So it's going to plot mag data versus f data. It's going to plot the magnitude of h1 versus freq. I don't see anything here, so let me let me turn on the symbols for a moment. That might help me. Yep, okay, it's up here, and it's evidently only plotting over the range of 1 to 10. I notice that the upper limits here are set automatically at this point based on the data set that I'm plotting. I'm going to override that by actually writing 10 to the 6th. That should force the variable, independent variable frequency to be defined over that range, which it does. And I'm going to go back and get rid of the symbol. I don't need that. In this case, I'm going to plot a solid line, and I don't know. We'll put a label here. We'll say this is experimental or measured data, and this is theoretical data. Show the legend. There we go. Okay, and we see now that, see if I make this bigger than this. Hold on. Probably go to 100, yeah, because it's on a log scale. So we see that the data correlates well with the theoretical values up to about this point here at 33 kiloradians per kilohertz, and after that it falls off a bit. Okay, we can do the same thing with, in fact, yeah, we can do the same thing with the phase. I guess I would do arg of h sub 1 of 1j times 2 times pi times frequency, and plot this versus frequency. I have the same problem. I need to set the upper limit to 10 to the 6th, and I need to plot it in degrees, not radians. And there we go. Now let's plot a solid line. Brown, and you can fill out the legend and so forth. So here we go. Okay, so that's how you can work with Excel data by embedding the Excel spreadsheet itself into MathCad. Now I should note or point out that there is no discrete or standalone Excel file. It is actually saved inside of this MathCad spreadsheet. It is part of it, and so if you want to grab this and put it on another machine, all you have to grab is the importing Excel data camtasia.xmcd file, and it will contain the Excel file as well, or Excel table as well as the entire MathCad spreadsheet in it. Okay. The disadvantage, of course, is that if you put it on a machine where you don't have MathCad, you can't get to the Excel data because it's not an external file. Let me show you just a couple more things with regards to working with arrays in MathCad. So I'll bring in this raw data again, right here, f sub raw, and you can access an element from that by, let me show you where it is. Bring up the vector and matrix toolbar, and you see this subscript here. This will look just like the symbolic subscript when we did f sub raw and we pressed period to make a subscript, but this is actually an index. So this has mathematical meaning. So I can press the open parentheses, open bracket. It puts another subscript, and now I can type, for instance, 0, and it returns the first element. I can type 1, returns the second. I could do something like this, like I is equal to 0 to 2, and then I could write f sub raw, open bracket, I, press equal, and it's going to enumerate the 0th, first, and second element. I can also, if I don't know the size of an array, I can use the length function. So length of f sub raw is 6. Then I could do something like this, where I would go length of raw of f sub raw. I should do -1, but I'm going to purposely do not do that, and then I get an error and it says this index array is invalid for this array because it's overstepped the bounds of the array. So I really want length -1 because it's a 0-indexed array. Now we get all 6 elements. Okay. Let me show you one other thing. You can actually, let me hold off on that. I'm going to now show you how you can work with data from Excel, from an external Excel spreadsheet. Okay. So we're going to access this. Oh no, the whole thing's been done. Oh crap. We're going to go to File. Not File, I'm sorry. Insert. Insert. Data. And then File Input. Wizard comes up like before. We're going to pick Microsoft Excel. And then we put in, let's see, I'm going to browse to the file, click Next, and you have a named range. You can use that, or you can actually specify the range. So let's look at what I want to import is from B8 to E13. B8 to E13. Okay. There you go. And I'm going to call this raw. Now it turns red and doesn't tell me what the error is, but I know what the error is. It's because this is open. So I'm going to close that. And then you have to actually go, like, double click it. Now it turns black. So if I evaluate raw, you now see that I have this table. I want to extract from that my 4 arrays. So let's go f's of, I'll say just f's of d instead of data is equal to. And then what I need to do is I need to pull off the first column. So I'll go raw. Then there's a column index. So it's this guy right here. It's Control 6, which makes sense if you look at it on the keyboard because above the 6 is the caret, which you use for doing the exponent. So instead of doing Shift 6, you know, when you're raising something to an exponent, in this case you do Control Shift. So it's pretty intuitive. Oops, I did 2 of them. And I'm going to say 0 because I want the 0th column. And let's see if I hit equal. Yep, that's the right one. Now I wasn't finished. I want to, at the same time, go ahead and give this some units. So there we go. Then we have dt data is equal to raw Control 6 1 times microseconds, and then xd is equal to raw Control 6 2 times millivolts, yd equal to raw Control 6 3 times millivolts. Okay. Now I can define my mag d again as, what was it, yd over xd, and I should go ahead and vectorize it just to be a good boy. We'll say phase, that phase of d is equal to 2 times pi times delta t d times f sub d. I need to remember to vectorize that one for sure. Oops. Okay, there we go. So let's just try plotting this in here. I'll go grab. You know, when you want to scroll up and down quickly with the scroll bar, you can hold down the Control key and it allows you to move much more quickly. So let me grab both of these, copy, go down here, paste them, and now I simply need to change this from mag of data to mag of d. We'll see if we get the same thing. Yep. And from phase of d. Forgot my minus sign. Okay, there we go. Now, something I'm gonna mess this up for a moment just to try to catch some issues you might have. This could occur in either case, whether you are embedding or just importing data. So I'll go up to the embedding because maybe that's what you're more likely to do. Let's say that I'm going to right-click and change the output range because I'm now going to add some more data. Okay, so instead of going from A7, I'm going to go to A11. I'll have 10 data points. Oops, C11, D11. Okay. Now I have a problem. This turns red, and if I click on it, it says divide by 0. Well, the reason is because the cells below here, let's expand this a bit. Double click on this, and then I want to show that data, so I'm going to draw this down some. Okay, I've got zeros down here, nothing, they're blank. So I must have some zero valued X data. So I've got to fool it. So I can go over here, and we'll just add, if I look at the scale that I have here, I'm looking at, millivolt scale. So let me just add a nanovolt. That's not going to make any difference to me. And now everything's behaving well. Okay, well, to summarize, I've shown you how to insert or embed an Excel spreadsheet into a MathCad spreadsheet so you can use its data. I've also shown you how to link to data from an external spreadsheet. And there's trade-offs between the two. So when you embed the Excel spreadsheet, the advantage is it's all contained within one document, that is the Excel or the MathCad document. You also get to see the actual Excel spreadsheet right there in the MathCad document. And of course, the drawback is you can't access that data outside of the MathCad document. So if you no longer have MathCad, or if you lose the MathCad file, you lose the data, or you can't view the data. The advantage of having the external spreadsheet is that you can access that using Excel without having MathCad. The drawback is you don't actually see the Excel spreadsheet within your MathCad file, and it seems to only update. I'm not sure. I think the data is only imported or updated when you open the spreadsheet or when you double click on the object, and it will re-update the data. I should mention one last thing, that you can do something as simple as this. Let's say I go back and open my spreadsheet here. I could literally, and you can do this, I'm just to show the point, I could go in here, grab all of this, Control C, and go back over to MathCad and paste. Now, paste special, let's see what that says. I can paste a picture, but I can actually paste the Microsoft Excel worksheet. Okay? If I double click on this, I'm actually in Excel. Okay? So this is another way of quickly putting data into a MathCad spreadsheet. The difference is here, we haven't linked the data that's in the spreadsheet with the MathCad, with any MathCad variable. So it's not like I can now grab the data in this table and use it. This is just, the MathCad spreadsheet is a repository or a container for this Excel spreadsheet. And yes, it is contained within the Excel spreadsheet, or the MathCad spreadsheet, so that if I take my one XMCD MathCad file and put it on another machine and open it up, I will see my Excel spreadsheet inside it. So that's an advantage. But again, in this case, I can't actually access the data. It's just really more there for graphical purposes. You can do the same thing with Word. So if at some point you want to do a write-up for your lab, and you find it along the way, it's easier to do some of the text formatting, to write a couple paragraphs that are mostly verbose. To do that in Word, you can do it in Word and then just literally grab that, select that, copy it, and go over to MathCad and paste it in there. All right, that concludes our tutorial.